Hello everyone, welcome to this session. In the previous sessions, you have already learned the fundamental knowledge of neural networks. And in this session and the next one, we will use two cases and we build neural networks using the MATLAB deep learning toolbox. So till the end of the specialization, we assume you already have the ability to learn from the online documents and the MATLAB function help files. So what I will do is to briefly explain the procedure and leave you more time to self-study based on the provided materials. Okay, now let's start the first case. So in this case, it's a regression problem. We want to learn the sound pressure of aircrafts. So there are 5 inputs, which are the frequency, the angle of attack, the chord length, the free stream velocity, and the function side displacement thickness. And the only output is a scaled sound pressure level. And we can see it here. So we can see that the data of different scales, right? So remember this, and we will see it later. Then we will make arrange the data set to the training and test. So here we introduce the new function we call it divide run. So this one, normally we can divide the data set into the training set, the validation set, and the test set, right? So more details you can see through this hyperlink. So here, to make it simple, I only make the training data and the test data, right, using this function. So I get the training set and the test set. So you can see the live script. Now I will construct a neural network. So let's see what this problem is. So 5 input, 1 output, right? So we will construct a neural network based on this. Then we will start from the simple network structure. Then I would use a 1 hidden layer with 20 neurons. These are the empirical guess, right? And I use the ReLU activation functions. So here we can see the 6 input, we do the 20 neurons and 1 output, right? So this is a neural network that we want to build. So here, to build this neural network, you can see there are many functions here, each one with hyperlinks. So you can go to them and see what does these functions do and how to set them, right? This is your homework after this session. So now we first build the neural network. So I first provide the input layer with 5 inputs. Then I build a fully connected layer, right, with 20 neurons. So this is the hidden layer. So then I said, okay, ReLU layer. So this doesn't mean this is another ReLU layer, another layer with the ReLU activation function. This means that this layer with the hidden layer have the ReLU activation function. Then I provide the output layer with 1 output. Then this is a regression layer. So we can see this is we build a neural network. So for details, you can look at that, right? So now we already have the neural network that we have planned. Now we can set the options in training. So we set the Adamo optimizer. We have introduced this before. Maximum epochs. So what is the epoch? The concept we have introduced before. So from this sentence, we can see that which kind of batch training am I using. So there are also other settings, and you can see in the MATLAB help file. Then we train the network, training data, layers, and options. Then this neural network is trained, right? We call it net. Then we can use a predict function, and that's use a test data to get the y-predict, right? So then we can see the root mean square error function to see what is the accuracy of this model. So we can see the root mean square is 30.21, right? So this is the first result. Then we can see if we can improve this network. So remember, as I mentioned before, right, the inputs are of various scales, right? So the first thing we consider is to add the normalizations to it. So here I add the normalization option of the input layer. Right? So then all the others that are the similar, and I also increase some the the training epochs, right? And then you can see all the details. Then I train the net and I predict. We can find that from 30, we change to 12.8. Quite a good improvement, right? Now the next step, I'm trying to make a more complex neural network to see if the result can be improved further. So I make the neural network to be deeper and wider. So here I introduced 2 hidden layers, and each of them has 40 neurons. We can see here 40 value, 40 value, right? Then I keep the epochs to be 5,000, and I train it. So this time we can see the prediction error becomes small again, so 3.4, right? So my question is that, is this a more complex neural network overfitted or not? And how can you say that, right? So you can see it and try it after this session. So all the details are in the live script. Okay, thank you. Bye-bye.